We're going to graph piecewise functions today. A piecewise function is going to be a combination of one or more functions. A step function is a piecewise function where we need to take into consideration the interval for which it is domain. Remember, when you graph an interval notation, that square brackets are include the endpoint, and parentheses do not include the endpoint. So here's our first example. We want to create a table and a verbal description for the graph that's represented. So the x-axis represents the age in years. The y-axis represents the price of the movie ticket in dollars. So the first part of our graph, this horizontal piece, represents the price of the movie ticket from 0 to just before 10 years of age. So I'm going to put 0 to, 12 years. Looks like 12 there. So open circle, 12 years. And the price on the horizontal axis here is $5. Then it jumps up the next horizontal piece at 12. So we go up to here, read that number, at 13 years, and then stops, we're kind of approximating here, 54 years. It's more of an approximation. I'm kind of approximating what I think that number is. And the cost is $9. And then the next horizontal piece, the price drops back down, and the age there is 55. And then notice it does not stop. So we'd say 55 and older plus, and the price is back down to an average of, looking at the middle there, across is $6.50. So we're going to state the intervals for the domain. So we'll say 0, so 0 to just before 13 is anyone from 12 and younger. Then we have the 13 to just before 55. And then we have those who are 55 and older. Step 2, write a verbal description. Use the intervals that we just created and the prices. So movie tickets that are $5 for children 12 and under. So that was the first piece. $9 for those who are 13 to 54. And $6.50 for those who are 55 and older. So that would be our verbal description for that graph. And then we have a check for understanding, so we're just going to go hold off on that. So we'll do that one in class. All right, continuing on, we have a piecewise function. That is a constant for an interval of its domain, such as the ticket price is called a step function. You can describe the piecewise function with a function rule. The rule for the movie ticket and price is an example from 1. So here is a function, f of x, so 5, if we have x greater than 0 but less than 13, and then f of x is 9, if we have x greater than equal to 13 but less than 55, and then 6.5 if x is greater than equal to 55. So then it says, for the piecewise function, evaluate for the following. So these are our domain values. So we're evaluating the domain, which is our age. And our output will be our cost. So f of 1. So if our age is 1 year, what will be the cost? So we go up to the domain. So our domain falls in this first group. So between 0 and 13, what would be the cost? The cost would be output $5. The next one, 9, f of 9. So now we go to our age group of interval from 0 to 13 again, and our output is also 5. Now we're going to go to f of 14. So now our age group falls in the second domain category. F of 14, we're going to output 9, so $9. Our last one, f of 55. So our age group now, our domain is 55. So 55 is right here. So the output will be 6.5. Example 2. Evaluate each piecewise function for f of x equaling -1 and x equaling 4. And here is our piecewise function. So the first one is f of -1. So we have to choose the appropriate piece depending on the domain restriction. So f of -1, so that would be in this domain, because x is less than or equal to 2, so we're going to evaluate this piece right here. So we're going to substitute -1 into that function piece. And then we simplify it. So 2 times -1 is -2, plus 1 is -1. The second one, evaluate it for 4, f of 4. So now we have to choose the appropriate domain. Now this is x greater than or equal to 2. That's the domain restriction. So now we're going to evaluate for this piece. So we're going to substitute 4 into that piece. And we simplify it. 16 minus 4 is 12. So f of 4 is 12. All right, here's another one. We're going to evaluate for the same numbers with a new function, f of -1. So -1, here's -1, says x is less than or equal to -1. So here's its domain. So we're going to evaluate it for right here. So 2 to the -1 power. We can just use our calculator, or we can go by hand. That's a 1/2 power. Second one, f of 4. Well, that's this domain, because our domain is x greater than -1, and that falls in that domain. So evaluate it for the second piece. So then 5 times 4 is 20. You can graph a piecewise function by hand by graphing each piece of the function. So here is our piecewise function. So we're going to first graph this piece of the function. So I'm going to go ahead and just go right down below. Y equals 1/4 x plus 3. And I'm going to ignore the domain restriction of x less than 0. So I'm just going to graph that line. I'm going to say, all right, the slope of that line is 1/4, and the b is 3. So that means then my y-intercept is 0, 3. So I'm going to go over, graph my y-intercept, 0, 3, and then I'm going to do my slope. So I'm going to go up 1, right 4, or down 1, left 4. And I'm going to create that line. So there is the line. Now I need to take care of the domain restriction. So here's the domain restriction. It says x has to be less than or equal to 0. So here's 0. I go up to the line. It has to be less than or equal to. So it's going to be everything less than or equal to. So now I have to erase all of this right here. All right, the second piece. I'm going to just write y equals negative 2x plus 3. I'm going to graph that line. So my slope is negative 2 over 1. My b is 3. So I'm going to have the same y-intercept. So I'm going to create that point. And then I'm going to do my slope. So I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, or up 2, left 1. So here is my line all the way without any domain restrictions. And now I'm going to go ahead and take care of the domain restriction. It says now x has to be greater than or equal to 0. So here's 0 again. I'm going to go up and find that point. So here's that point. I'm going to put a solid circle now because it's going to be equal to, and it's going to be greater than. So greater than is to the right. So I'm going to keep all of this. So I'm going to erase that little pink part. So what's left is that green and purple that creates the piecewise function. We will keep this one for in class.